Hi, everybody. Welcome back to the Stochastic lecturing series, Random Variable and Distributions. In this video, this is the second part of this lecture. And the first video, we discussed what is a random variable. Specifically, we talk about the discrete random variable. And then how do we construct the probability distributions of the random variables here. And in this video, we're going to talk about the last things for this lecture. The second part is we're going to define what is the distribution functions for random variables here, okay? And so just kind of do a quick review. So this is what we did on the video number 1. We defined the random variable, and then we defined what is the probability distribution of random variable, and what are the key conditions you need to satisfy in order to be a probability distribution for random variables here. Like that means each one, they have to be greater than 0. When you add all the probability together, it has to be equal to 1, right? Because it's over the sample space. Okay, so now also we did like the 3 problems about the probability distributions, and we stop here. Okay, so for the second part of this lecture, this video, we're going to cover a very important concept also. We call this distribution function or cumulative distribution functions. And the same like before, we're going to talk about a couple theories associated with the distribution functions. Then after that, we have 2 problems we're going to work on, and that's it for this lecture series. So let's get started, okay? I'm going to the whiteboard here. Let's go to started, see what is the, the distribution functions here. So the distribution functions, okay, so distribution functions, we also, the most common, you can call the distribution function, but the typical we call it is the cumulative distribution functions here. And you will see the abbreviation, we call it the CDF. Okay, that means the cumulative distribution functions here. So what is the distribution functions, right? So the distribution function, so from the video number 1, we know a random variables, and then you have the associated, we call it the probability distributions, right? So that's what, let's do a quick review about what we did in the first video, and hope that you still remember, right? So we said, well, after you defined random variables here, right? So for example, we use like a number of head where you toss 3 coins, we have 0, 1, 2, 3, right? Then we say this is the probability you get a 0 head, 1 head, 2 heads, and 3 head, right? So we say this is 1, 8, 3, 8, 3, 8, and 1, 8. So the PX is here, and the whole thing, this is we call it probability distributions, right? So because that's how the probability distributed to the different values of the random variable. So the PX here, we call it a probability distribution functions. Some people call probability density functions. So sometimes we use the notation, we said is the PDF here, right? So the cumulative is the CDF. So what is the CDF? So this way we define the CDF here. We use the capital letter F. So if you say the CDF of the, let's say here, CDF T here, that means you have these probabilities here, right? So you add all the probability X is less than or equal to T, and then you add all the F of X. So like in here, if I say, so for examples here, for these examples, right? So this is for examples here, for the number of head. So if I say f of the 2's here. What means? That means that I add all the way, I add the probability density function all the way to 2. So that means I add 1/8 and 3/8 and 3/8. So this is that's why it's a cumulative, right? That's why it's a cumulative, so it's a 7/8. So that's why we use this notation. We will say it's a probability x less than equal to t, right? So that means it's the random variable less or less than equal to whatever you try to find is here, right? So that's why we use the word cumulative, because you kind of adding them up. Okay, so now we have a few theorems. It's kind of like intuitively true. So the first one is here. We have okay, so like the first thing here. So if for the CDF, the negative infinity, remember the random variable is a function. They change everything to a real number, right? So they map every element in the sample space to a real number. So if here is negative infinity, that means that you add to the you add your probability value to the negative infinity, you don't really have anything, right? So it's 0. Then on the other end, so if you add to the infinity, so that means it's going to cover all the values of x, right? So that means when you add all the way, what is here, it will give you 1s here, right? So that is kind of like the obviously is true, right? Like in here, right? So for these examples here, if you say what is the f of the infinity, that means you add 0, 1, 2, 3, so you should add 2 1s here, right? Okay, so let's take a look at the second theory here. The second one is here. They tell you also this is kind of intuitive truth here. So let's say if you have the true numbers a less than b, all right, and then your f of a will less than f of b here. That's kind of intuitively true because the f of x is the cumulative. They're cumulative to a, they're cumulative to b. So if a is less than b, of course the cumulative to a will less than equal to cumulative to b here, right? So this one is kind of a simple, trivial to understand here. So this one's here, right? So if I have a number x1 less than x2 less than x3, all right, and to the xn's here, then I know the f of x1 is equal to the cumulative of x1, right? Because you just add 1 itself. So how about if I want to find the xi? So the xi here is, this is f of xi minus f of what? Xi minus 1. Okay, so in order to demonstrate this concept, I kind of like to use like a line to represent that. Okay, so here, let's say here, right? So this is x1, and then this is x2, this is x3, x4, x5 to xn's, right? And okay, so I want to put a color coding here. So top here, this is f of x1, this is f of x2, this is f of x3, f of x4. So the top is just each individual probability to f of xn's here, right? Okay, now the bottom is cumulative, right? So the first thing is I cumulative to x1. So this is my f of x1. So it's nothing before x1. So I cumulative to x1 is just x1. So that's why this one tell you if x lowercase f of x1 is equal to the uppercase f of x1. Okay, now what is f of x2? That means I'm cumulative, right? I cumulative from here all the way to here, right? So I have here, I have here. So this things here is f of what? F of x2s, right? Okay. Now, the same way is here for the f of x3. I should have a little bit bigger. Maybe it would be better. So here, okay. So yeah, so you can see here, the f of x2 is to here. Now, this is f of x2. Okay, so now the f of x3, you cumulative all the way to where? To x3s, right? So see here, right? So if you use the f of x3 minus f of x2, what you get here? You use the f of x3 minus f of x2, you minus everything out except what? Except this number, right? So that's why this will be equal to the what? So this will be equal to f of x3s here. Did you guys see here? That's why is this formula tell you, right? So the same way is here, look here, from here, right? So if you use the f of 2 minus f of 1, f of 2 is the sum of the f of x1, x2, minus f of 1. So what do you minus out? You minus this part out, right? So you minus x1 out. So what do you have left here? You have left is lowercase f of what? F of 2. So that's what is this formula try to tell you. So you can always use what they up to, right? And minus the one before. You see here, so like for these examples here, right? Okay, so these ones here, if I say, let's see, to go backward will work on that. So like in here, we say f of 2 is just like we calculate here, is 7/8, right? Okay, so now I want to say f of 1. F of the 1 is 1/8 plus 3/8, right? So it's 4/8. So now, if I use the f of the 2 minus the f of the 1, so what I have here, I have a 7/8 minus 4/8. What is give me? 3/8. That's true. So what is 3/8 here? So the 3/8 is equal to what? F of 2, right? Or we say this is the P2. I'm sorry, F of x2, so it's f of second position, so it's a p when the x is equal to 1, right? Because the 7/8 here, this is when the 1/8 plus 3/8 plus 2 3/8, right? So this one is x equal to 0, x equal to 1, x equal to what? X equal to 2, right? So when you use f2 minus f1, so that's what happens here. You got f of 2. So I'm sorry, this is x equal to 2, right? So that's what you get 3/8 here. All right. Okay. So like I said, for this ones here, this is super important formulas, right? So this is the one. This is also will help you to change back to the CDF to the PDF. All right. So remember, we talk about a few key things here: the CDF definitions, the PDF, and this is the main formula. Will help you to change back and forth from the CDF to PDF, PDF to CDF here. Okay, now I know you guys still got very confused. So now let's take a look at this example. We did this example in the video number 1 here. So I'm not going to redo the probability. I'm just going to write it out. So this is the example we did in the video number 1, first part of this lecture. If you don't remember, go back there to review. So we say we have 5 brown socks and 3 green socks. And the random variable W is defined, and the number of what is the number of the brown socks. So we know we can have 0 brown socks, 1 brown socks, or 2 brown socks. And from the video number 1, we already calculate, you know, we already calculated the probability. So get the 0 brown socks is 3/28. And get 1 brown socks is 15/28. Get 2 brown socks is 5/14. So like I mentioned, this is the first problem in the video number 1 for this lecture series we talk about. All right. So for this topic is here. So go back to review the video we just did. Okay. So now they said here they want to ask to find the distribution functions. Okay. So the distribution functions, right? So just like our definition, we say the f of x, so what is the distribution functions here? So the f of x here, right? So f of x, the lowercase x, right? That means the values, right? So so this is our definition, is the probability of a random variable greater than or equal to the lowercase of the x here. So this is our cumulative distribution function definition or distribution function definitions here. Okay, so now we have a w's here, right? So basically this one's here, you will say this is the fw is equal to the w less than equal to w's here, right? Okay, so now the first things here we know. Okay, so in here, make sure we recognize here we have 3 values, 0, 1, and what? And the 2 here. Okay, so now let's take a look here. So if I have f of 0, what's that mean? That means that I add all the way to 0. So what is here is 3/28. Okay, so now if I have f of 1 here, right? So f of 1, based on my definition, is a probability w less than equal to 1. So that means equal to the w equal to my random variables here equal to 0 plus the random variables here equal to 1, right? So what I have here, I have a 3/28 plus 15/28. So I will have 18/28 or 9/14, right? So now I can do the f of 2 here. So f of 2 is a probability w less than equal to 2. So that means it's a probability w equal to 0 plus w equal to 1 plus w equal to 2, right? So we did this, so it's 3/28 plus 15/28 plus 5/14. So what do we have here? We have 1s here, right? Okay, so now let's try to write the probability distribution function. Then we will graph it, all right? So this is how do we define. So this is, we say, okay, this is fw, right? Okay, so because my value start at 0, so I know I don't have anything, so it will be 0, nothing to accumulate if w less than 0, correct? Okay, so as soon as the w hit 1, hit 0, right? So this is hit 0 less than 1. So from the 0 to 1, we just say from 0 is what? Is 3/28, right? Okay, so then the next level is when I hit 1s here, right? So it's 1, but less than 2. That means I add all the way to 1. So all the way to 1 is what? 9/14, right? Now the w going to hit what? Hit 2s, right? So what is w hit 2? So will be 1s, right? Anything greater than that will be 1. Correct? All right, because that you can, because w greater than or equal to 2, there's nothing else to add. So it's 1 here. Okay, now let's take a look. How do I graph it? This is kind of like, okay, so this is the, let's see here. All right, here. Okay, so in here, okay, so this is zeros, right? So let's make it. So this is 0, this is 1, this is 2. Okay, so I know, okay, so here it is how I'm going to graph it, right? W less than 0, the probability is zeros here. So let's say this is my W value, this is my FW values here. It's less than 0 is 0. So from the 0 to 1, from 0 to 1 is what? It's 3/28, right? So here, right? So 0 is a solid dot, right? Because here the equal sign. 0 to 1. 1 is a circle. What is the height here? This is 3/28. Okay, now from 1 to 2, right? From the 1 to 2. Okay, so from 1 to 2 here, 1 will be included here because the equal signs here, 2. And what is the value? 9/14. So here is 9/14. And W greater than 2, so here is what? Here is 1, right? So that means when W greater than 2, it will become 1 here, right? That what is recalled is the cumulative distributions. So for the discrete, typical it will be a kind of the step function, it's a jump here. Okay, so this problem here is a given PDF. How do I find the CDF? So my next problem here is going to say, hey, I'm giving you this CDF. How do I find the PDF? So you guys need to be extremely good at the back and forth, right? So these examples here, this is the given, the probability density functions or probability distribution function. Then you want to find CDFs here. So you want to find the cumulative distribution functions here. Okay? Very fun, right? Okay, now let's take a look at the next ones here. Okay, so the next ones here, right? So if X has a distribution functions like this, I want to find the probability distribution. That's me. So I have a few things I want to find here, right? So X is from the 6 to 2 to 6. I think here there's an equal signs, right? The 2 to 6 here. And then the second part is to find X equal to 4. Now I want to find the probability distribution functions of X. All right, so if you want to do, you can, we can do it, let's try to, you can kind of scratch it, do a graph first and then get an idea. Okay, so, oops. Okay, so here I'm drawing here, right? So here. Okay, so here, okay. Okay, so let's take a look. How do I get from this is a CDF, right? So it's a given CDF, and I'm looking for the PDFs here, right? So this is the 0, this is the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then this is 1, 2, 3, 4, 5, 6. Okay, so this is 1/6, 2/6, 3/6, 4/6, 5 over 6 and 1. Okay, so let's take a look at the graph here, right? So let's say less than 1 is 0. So that means really nothing to accumulate, right? So it's less than 1, so it's here, this is 0. From 1 to 4, so this one's the equation, the equal signs here, so it's 1/3. So that means I'm jump over to here, right? From 1, so it's 1/3, right? So it's 2 over 6 to 4, so it's all the way to 4 here. The 4 is a circle because I don't have an equal sign. Okay, then 4 to 6 is 1/2. 1/2 is 3 over 6, so it's here. So 3, 4 to 6 is 1/2. Okay, now the 6 to 10, so the 4 is solid, right? Now here, the 6 to 10. So 6 to 10 is 6, 5, 6. So it's 6 to 10, all the way to 10. 10 is a circle. It's 5, 6 here. Then greater than 10, so this is 1, right? So this is the graph of my CDF here, right? Okay, so now I know in here how many jumping points here. I have how many? I have 1, 2, 3, 4. Correct? I have 1, 2, 3, 4. So I know my random variable value have 4 values. What are those 4 values here? My random variable x is here. So if you want to, because later we're going to create this table anyway. So I know my x values here going to be what? 1, 4, 6, and 10. That's right, because they jump at these points here. Okay, so now the part A is here, right? So this is the probability they want to find 2x is less than or equal to 6. Okay, so you take a look here. They want to find is the probability x greater than 2, but less than or equal to 6. But x only can have 1, 4, 6, 10. So this is really is equal to x equal to 4 plus x equal to 6, right? Because x has to be greater than 2, so 1 is not, and x only can be 1, 4, 6, 10. So this equation basically tells us is x equal to 4 plus x equal to 6 here, right? Okay, so now the x equal to 4, okay, so x equal to 4, 4 is here, right? So 4 is, so 4 So 4 is here, right? So 4 is really is the 1/2 minus what? Minus 1/3, right? You see here, 4 is here, right? 4 is here, so it's from this point to here. So that means they jump that much. And then now x equal to 6, right? 6 is from here to jump up to here. So what is here? This is 5 over 6 minus 6 is here, right? Right, so it's 5 over 6 minus what? Minus 1/2, right? Okay, so this is 1/6 plus 5, 6 minus 1/2 is 2, 6, right? Okay, so it's 2, 6. So now this is 3 over 6. So we have what? We have 1/2. Or remember, we can use this formula here, like I mentioned here. So f of xi is equal to, you can use the two things to minus. That's what we use these ones here, right? Okay, so now if you want to do in other ways here, so the x is from the 6, right? And to 2. So the 2 is here. So really is, so this one's here, or you can rewrite this one is f of what? F of the 6 minus what? Minus f of what? F of 1s, right? So f of 6 is what? f of the 6 is the 5/6 minus f of the 1. F of 1 is what? 1/3. So it will give you what? Will give you 1/2. So you will get the same answers here, right? Because when the f6, that's what is here, the 4, you are trying to minus is this f of 1. Kind of a little bit confusing, right? Okay, so now the second one is here, the B is here. I want to find the probability of x equal to 4, right? So we already did the x equal to 4. You basically is from here, right? So you can say, so this will be equal to the 3/6 minus 1/3, right? So this is what? So this is 1/6. Correct? Okay, so now this is the part B. So now we want to find my PDF here, right? So, okay, so let's see if we can do that or not. And so this one's here. Okay, so let's see here. This is my X value, and this is my F value or P value. Or you can write this is PX, it doesn't matter. So in here, we already know my X value is only have 4 values, 1, 4, 6, 10, right? Okay, so f of x1 is here, right? Because before that is 0, then jump to what? 1/3. So f of x1 is easy. So this is 1/3. Okay, the 4, right? So this is the 4, right? So we need to use the 1/2 minus, so you minus the previous one. So 1/2 minus 1/3 will give you what? Will give you 1/6, right? So here, let's try to do this one more time. This is 1/2 minus 1/3. That's why I give you 1/6. Okay, let's take a look at the 6s, right? Then the 6 here, the 6 here is f of 6 minus f of 4. So what is here? The 6 here is 5/6 minus 1/2, right? 5/6 minus 1/2. So this is 2/6. All right. So how do I get this one? It's 5/6, right? Minus 1/2. Clear? Okay, so now f of 10 is 1, right? So 1 minus what? 5/6, so it's 1/6. So this one's here, this one's here is 1 minus 5/6. Okay, so let's check to see I did it right or not. So remember, everything add up has to be what? Has to be ones, right? So it's 2/6 plus 1/6. So this is a common denominator, 6. This is 2 plus 1 plus 2 plus 1. Ha is 6, right? So 6/6 is 1. Okay, so that what is this? The part C, this is our probability distributions, right? So then this function f of x here, this is we change to the PDFs, right? Okay, so this problem here is, so be careful, this is given CDF, right? Given cumulative, then you want to find the PDFs here, okay? So we're going to do this a lot, especially in the next few lecture series when we talk about the continuous random variable or discrete random variable. So you need to know, for a given CDF, how do you find the PDF? Or from like our previous example, given a PDF, how do you find the CDF? All right, okay, so that's it. So that's it for this lecture, and looking forward to talk to you to the next lecture series, and we're going to take a look at the different things about the random variable and the different properties about the distribution functions. All right, so nice to talk to you, and you have a good day, and I'll talk to you later. If you like the video and think it's helpful, feel free to subscribe it, so every time you will get notified when a new video was posted. Okay, bye, and talk to you later.